Sorry, I ran out of storage. so, but the thing cut off. So I'm gonna try a while loop. Do these for a while. Let's see if that fixes it or breaks it. Hope it fixes it. Nice. Cool. Yes, that's very unfortunate timing on the recording stopping because I ran out of storage because it was almost done. But yeah, the solution just needed, instead of doing an if, because if you run into, because what would happen here with the 4? It would become 4. I don't even know what's happening with the 8 there, but yeah, that's the solution. That was honestly decent speed-wise. Speed memory-wise, pretty cool. So we're not using any extra memory, and we're not, decently fast. It seems like, because I mean it should be like O of n time. Let's see what some other people have done. Probably gonna be some pretty smart answers here. Return false. So they're doing the same thing I did basically. Yeah. Whoa. Oh. There's some funky stuff here. I want to begin to start to. Yeah. I think this is log n. Time. Complexity. Okay. Take their word for it. Yeah, so that's the solution. Just gotta change these to while loops. Cool. Basically what's happening is, we're saying if n is greater than or equal to 1, we're going to check, okay, can the number be divided by 5 and leave no remainder? If it can, we're going to divide the number by 5 as many times as we can until that's no longer true. Then we're going to check, okay, now can the number be divided by 3 with no remainder? If it can, we're going to divide that number by 3 until that's no longer true. Then we're going to check, okay, is our number, can it be divided by 2 with no remainder? If it can, we'll divide that number by 2 until that's no longer true. And then we'll check, okay, is the number equal to 1? Because at this point, any ugly number divided by 2, 3, and 5, as many times as those numbers go into itself, it's going to equal 1. So we're going to return true. Otherwise, we're going to return false. And this also works for negative numbers because we're going to say if n is greater than or equal to 1. Okay, that's not true. Else, we're going to return false. That also just kind of checks for negative numbers. Yeah, so I mean, another way to explain that is like, for like 12, how I did 2 and 6 to start, you could also, 12 is also divisible by 4 and 3. But if, and then 4 divided out is 2 and 2, so you get 2 2's and 1 3. 12 divided by 2, split up into 2 and 6. 6 split up is 2 and 3, so still you get 2 2's and 3. So no matter how you kind of divide, it doesn't matter the order you divide the prime factors in, you're still going to end up with the same number of prime factors. That's why it works.